Okay, is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by a differentiable function f, where f of t is measured in gallons per second and t is measured in seconds since pumping began. Selected values of f of t are given in the table. Okay. Using correct units, interpret the meaning of integral of f of t from 60 to 135 in the context of the problem. Use a right-Riemann sum with the three subintervals 60 to 90, 90, 120, and 120, 135 to approximate the value of integral of f of t dt from 60 to 135. Because f of t is gallons per second, when you take integral, you can cancel this per second because you integral ft dt, and you can say number of gallons that you have from 60 to 135. So it says pumping gasoline into gas tank. So the rate of flow, so number of gallons flow, you can say flows into gas tank, into the gas tank from T60 to T135, and as you can see seconds, so seconds. Okay, correct unit, number of gallons, interpret, and then it says okay, use a right Riemann sum with the three subintervals 60 to these parts. So let's solve a new page. Okay, now we want to calculate these parts 60 to 90. So if I draw the diagram from 60, the first interval 60 to 90, next one 90 to 120, and last one 120 to 135. So from 6 to 90, because we want to use right Riemann sum, so if we calculate this part, let me select. Okay, the first one, we calculate right Riemann sum, f of this. 90 is what? 0. F of that is 0.15, so this level. And for 120, it will be 0.1, so this part. F of this point, we can say is this. F of this point is 0.1. And the last but 135. So it will be something like this, which is, if we calculate, 0.05. Okay, now we should calculate these areas. So the first rectangle is what? So right Riemann sum equal to, and we know integral of 60 to 135 f of t dt is approximately right Riemann sum equal to, this part is 30, this rectangle, times this part, which is 0.15, plus this part is 30 times this length, which is 0.1, plus this part is 15 times this part, which is 0.05. And in this problem, we can use calculator, and it is equal to 8.25. The unit is gallons. Okay, it was part A, this problem. Let's solve part B. Part B says, must there exist a value of C for 60 to 120 such that f prime c equal to 0? Justify your answer. Okay, so from 60 to 120. 60, 120. We know that f of 120 minus. So we want to find if we connect 60. For example, f of that is what? That is 0.1. We want to consider a slope of secant line. So if we calculate f of 120 minus f of 60 over 120 minus 60, f of 120 minus f of 60 is 0.1 minus 0.1, and 120 minus 60 is 60, so it will be 0, and it will be a horizontal line between them. And if we use the line between them that connect them, we will see it will be a horizontal line. And for example, for any function, we have a line that is parallel to this, and we call it MBT. F is, we don't know the exact function is similar to this. We can say f of x is differentiable, so f of x is continuous. And by using mean value theorem or MVT, we conclude what? There exists C, which C is strictly greater than 60, strictly less than 120, and f prime of C equal to is parallel. We can say this tangent line is parallel to this, and it is our C. So f prime of C equal to 0. Okay? So we proved part B. Part C says the rate of flow of gasoline in gallons per second can also be modeled by G of t equal to t over 500 times cos of t over 120 squared for t from 0 to 150. And also our table is from 0 to 150. Using this model, find the average rate of flow of gasoline over the time interval 0 to 150. Okay, it's part C. And it says show the setup of your calculations. For part C, we can say it's at the average rate. So when it says average rate of gasoline over the time interval from 0 to 150. So when we want to calculate average, it is continuous function, so we should calculate integral. It says from 0 to 150, integral of gt dt over this interval 150 minus 50. It is equal to average rate of flow of gasoline over this time interval. And if we use 150 minus 0. And if we use calculator, it will be equal to 0.095997, and the unit is gallons per second squared. Okay, and here we calculated this. Part D says using the model G define in part C, find the value of G prime of 140. Interpret the meaning of your answer in the context of the problem. Okay, so G of T is this. For this part, you should use calculator and G prime of 140. Okay, so G prime is this, negative 0.00491 gallons per here, because we take derivative, it will be second squared. And for previous part, for part C, because it was average, and we should say gallons per second. Okay, so it is this. Now it says interpret the meaning of your answer in the context of the problem. G of t was what? So G of t, the rate of flow of gasoline in gallons per second. So when it is equal to negative 0. This, it says interpret. You can say exactly this definition. The rate of flow of gasoline, the rate of flow of gasoline is decreasing by 0.00491 gallons per second squared at t equal to 40. Okay, so we've solved this problem completely. Okay, for improving your math, also I can say your problem solving, you can use my previous videos, for example, related to last AMC, last AME, and if you want to learn some specific things, as I said before in my previous videos, feel free to send message to my WhatsApp number in the description and comments. Problem 2. Stephen swims back and forth along a straight path in a 50-meter long pool for 90 seconds. Stephen's velocity is modeled by v of t equal to 2.38 e to the negative 0.02 t times sine pi over 56 times t, where t is measured in seconds and v of t is measured in meters per second. Part A. Find all times t in the interval from 0 to 90 at which Stephen changes direction. Give a reason for your answer. Okay, for this part, we should check the times that v of t changes from, for example, positive to negative or negative to positive. So we should find the times that v of t equal to 0. If v of t equal to 0, we know 2.38. If we replace v of t with this, e to the negative 0.02t sine pi over 56t equal to 0. And we know that this part is positive, so sine pi over 56 times t is 0. And if we consider our unit circle, sine t is from 0 to 90. So it will be from 0 to not 2 pi to some points like this here. And if you want to consider sine is 0 in what point? On this point, it should be pi. So in t56, it will be 0. So v of 56 equal to 0. And if you consider, you can see that in t56, v of t equal to 0. And after that, it is, if you increase, it will be negative. Before that, it is positive. So we can conclude that because the sign of v of t changes, we can conclude that the direction changes in t equal to 56. So our answer is t equal to 56. Part B. Find Stephen's acceleration at time t equal to 6 seconds. T equal to 60 seconds. Show the setup for your calculations and indicate units of measure. Is Stephen speeding up or slowing down at time t equal to 60 seconds? And give a reason for your answer. Okay, if you consider at time t60, we know after 56 it is 0, so v of 60 is less than 0. Now we should calculate also a of 60 to see is it positive or negative. Then we can say, at first we can answer acceleration is what, then we can answer that it is Stephen is speeding up or slowing down. A of 60 is what is v prime of 60. And we know that v of t is what? V of t equal to this point, 2.38. Let's write it 2.38 e to the negative 0.02t sine 5 over 56 t prime. And if you use calculator, it will be negative 0.03602. And it says indicate units. It will be meters per second squared. And now, because a of 60 is less than 0 and v of 60 less than 0, both of them less than 0, when we have this, then we can say Stephen is speeding up. Okay, when both of them negative. At t equal to 60 seconds. Okay, so we've solved part B. Let's solve next part. Part C. It says find the distance between Stephen's position at time t equal to 20 seconds and his position at time t equal to 80 seconds show the setup for your calculations. Okay, here, because we want to find distance between these two things, between exactly the positions, you should calculate from t20 to 80, 20 to 80. We should calculate vt dt, okay? We want to find the positions. So if you calculate this with calculator, it will be 23.384. Now let's calculate part D, last part. It says find the total distance Stephen swims over the time interval from 0 to 90 seconds. Show the setup for your calculations. For this part, because it says total distance and from 0 to 90, we should calculate 0 to 90, absolute value of Vt dt. And it will be 0 to 90. If you use, we should use calculator here, and it's equal to 62.161642. Okay, so you solve this problem completely. If you want to improve your problem solving, as I said before, you can use my previous videos and feel free to send message to my WhatsApp number in the description and comments to learn some important techniques for problem 3 of APBC 2023 is same as problem 3 of AP 2023 AB. So let's solve one of them. Problem 3 says a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. And the increasing function f models the temperature of the milk at time t, where m of t is measured in degrees Celsius. T is the number of minutes since the bottle was placed in the pan. M satisfies the differential equation dm dt equal to 1 over 4 times 40 minus m. At time t0, the temperature of the milk is 5 degrees Celsius. It can be shown that m of t is less than 40 for all values of t. Yes, if you solve this differential equation in one part, we will solve it. You will see that the horizontal, we can say asymptote is 40, y equal to 40. So part A, let's solve. It says a slope field for the differential equation dm dt equal to 1/4 of 40 minus m is shown. Sketch the solution curve through the point 0.05. So you should draw it approximately. You can draw, let me draw with other color. Okay, if you pass this, it will be something like this. It will be, you can continue like this. And it is our vertical asymptote, okay? Or if you draw it a little better, you can draw that. It will be something like this. Okay, and you can continue. So it wants only sketch. Let's try part B. It says use the line tangent to the graph of m at t0 to approximate m of 2, the temperature of the milk at time t to equal to 2 minutes. Okay, so for solving this problem, we know that in t0, 1 point is 0.5, and we want to approximate. We know if it says in t0 to approximate line tangent. So we know dm dt for this point t0, 0.5 equal to 1 over 4 times 40 minus m. M is what? M is 5. So it will be 40 minus 5, it is equal to 40 minus 5, 35 over 4, which is 8.3 over 4, 75. Just so. And here we want to approximate m of 2, so 2 m of 2. So this line is what you can say m minus 5 equal to this slope, 35 over 4 times t minus 0. Okay. And it is what we can call this one m of t. So m of t equal to 35 over 4t plus 5. And then the problem says approximate. It is approximation with this line. So m of 2 is 35 over 4 times 2 plus 5. And if we cancel 35 plus 2 times 5, 10. It will be 45 over 2 or 22.5. And if you want to determine unit, it is 22.5 degrees Celsius. Now, let's solve part C. It says write an expression for these 2m dt2 in terms of m. Use this to determine whether the approximation from part B is an underestimate or an overestimate for the actual value of m of 2. Give a reason for your answer. Here we can understand because it's concave down, it is overestimation, because for example m of 2, the real value is this, the approximation is this. But let's show with t squared m dt squared. Okay, if you want to calculate, we know dm dt equal to 1/4 of 40 minus m. So dm dt equal to 1/4 of 40 minus m. Now if we consider again, take derivative with respect to t, it will be 1/4 of negative dm dt. And it will be 1/4 of negative dm dt. Again, we can use this. It will be negative 1/4 of 40 minus m. And it will be negative 1 over 16 times 40 minus m. M is what? Because we're approximating 0, if you consider 0 and 5, when m is 5, it will be what? D squared m dt squared, negative 1 over 16, 40 minus 5. And it will be negative 35 over 16. It is less than 0. So because it is less than 0 when you approximate, in this point, the graph concave down. And we understand, okay, it is overestimation, okay? So it's overestimation. And this graph, because it is less than 0, concave down. Okay, last part D. Use separation of variables to find an expression for m of t, the particular solutions to the differential equation dm dt equal to 1/4 of 40 minus m with initial condition m of 0 equal to 5. Okay, when we have something like this in AP problems, I can say 90% of the problem, we should take all things to one side, like here, separation of variables. So I say dm, I take all things related to m to left side is over 40 minus m equal to dt over 4. Then we take integral from both sides dm, or we can write it as 1 over 40 minus m dm equal to 1/4 dt. Left side will be negative ln of absolute value of 40 minus m, and the right side equal to t over 4 plus, for example, c1. Then we can say, okay, ln of 40 minus m equal to negative t over 4 minus c1, because c1 is a constant, we can say plus c2. Then we consider, we know by also graph and the assumption of the problem is our graph is always less than 40. So 40 minus m here is positive. So we can say is equal to 40 minus m equal to ln of, let me write ln of, we can get rid of absolute value. 40 minus m equal to negative t over 4 plus c2. Then we consider e to the power of these things. So it will be 40 minus m equal to e to the power of negative t over 4 plus c2. Then we consider 40 minus m equal to e to the negative t over 4 times e to the c2. Then we consider c3, we define c3 equal to e to the c2. So 40 minus m equal to c3 e to the negative t over 4. Then we can multiply by negative 1, m minus 40 equal to c4 of e. And let me tell you something. c3, we can say c3 because it's e to the c2 is positive. So let's work on this. Negative c3 e, or we can call it c. Okay, negative c e to the negative t over 4, and we know c is positive. So if you add 40, m equal to 40 minus ce negative t over 4, and we know that c is positive. So it is what we can consider, because the problem says calculate m of t. We can say it is m of t equal to this. Okay. It says the particular solution to the differential equation. This with initial case of m of 0, 50, m of 0, 5. So let's consider if m of 0 equal to 5. Then we know 40 minus ce the power of negative 0 over 4 equal to 5. Okay, so we know that 40 minus c equal e to the 0 is 1 equal to 5. So when we take c, negative c to right side, 5 to left side, 35 equal to c. And because c equal to 35, so our particular solution equal to m of t, 40 minus 35 e to the negative t over 4. Okay, so we've solved this problem completely. If you had question or wanted to improve your problem solving, you can use my previous videos in AMC many other parts. You can feel free to send message to my WhatsApp number in the description and comments for improving your problem solving and other things. APBC 2023 problem number 4 for AB. Problem number 4 is same, so we will solve one of these fourth problems. So let's solve this one. It says the function f is defined on the closed interval negative 2 to 8 and satisfies f of 2 equal to 1. The graph of f prime here, the derivative of f consists of 2 line segments and a semicircle here. And this semicircle and 2 line segments as shown in the figure. Part A. Does f have a relative minimum, a relative maximum, or neither at x equal to 6? Give a reason for your answer. Okay, let's analyze x equal to 6. F prime is 0, f prime of 6 is 0. But we should check it near 0, it will be what? Near 0, as you can see in before 6, in 6 it is 0. Before 6, f prime positive, after that positive. So it is not relative minimum, because relative minimum is like this. Before that, it is negative because it is decreasing, after that positive. So for relative maximum, before that positive, after that negative. But because f prime of 6 minus and 6 plus, both of them are positive, it is the graph of f prime. So we can say neither. Okay. Part B. On what open intervals, if any, is the graph of f concave down? Give a reason for your answer. Concave down means what? Means f double prime should be negative. So f double prime means, okay, concave down means f double prime should be negative. So we can say because we have f prime is decreasing. So here in this part it is decreasing, in this part increasing, again in this part decreasing. And because it says open interval, so you can say from negative 2 to 0, negative 2 to 0, union 4, open interval, it says. You're right, 4 to 6. Okay, our answer is this, because f prime is decreasing. Let's solve C. Part C says find the value of limit of 6f of x minus 3x all over x squared minus 5x plus 6 when x approaches 2, or show that it doesn't exist. Justify your answer. Okay, when you want to calculate a limit Like this, you should replace first x with 2. So 6f of 2, and from assumption of the problem, we know f of 2 is 1. Minus 3 times 2. If we calculate, it will be 2 squared minus 5 times 2 plus 6. 6f of 2 is 1, f of 2 is 1, 6f of 2, 6, minus 3 times 2, 6, 2 squared 4 plus 6, 10, minus 10, 0, so it will be 0 over 0. So if we use Hopital's rule, we can say that by Hopital's rule, we can say limit of x approaches to 6f of x minus 3x all over x squared minus 5x plus 6 equal to limit of x approaches 2. You take derivative from both numerator and denominator. It will be 6f prime of x minus 3 over 2x minus 5. And if you replace x with 2, it will be 6f prime of 2 minus 3 over 2 times 2 minus 5. F prime of 2, because we have the graph of f prime of 2 is 0. So it was 0 minus 3, 2 times 2, 4, 4 minus 5 is negative 1. So negative 3 over negative 1 is 3. Okay, let's solve part D. Last part of this problem, it says find the absolute minimum value of f on the closed interval negative 2 to 8. Justify your answer. Okay, here, because we want to find absolute minimum, we should check relative minimum and also endpoints. Okay, so when we have relative minimum, it is something like this. F prime 0 or undefined, and before that it's f prime is negative, after that f prime positive. So if we check here, f prime in this part is 0, before that it is decreasing, after that also decreasing. So we cannot reach any good thing. Here we will see, okay, it is 0, before that it is increasing, after that also it is increasing. So f prime positive, f prime, sorry. Let me tell you, before this part, negative, it is graph of f prime. Negative 1, before that f prime is positive on top of x-axis, positive, negative. So it is, because look, when you have something like this, f prime positive, negative before that. So it is relative maximum. For this part, because before that negative, after that positive, so we should calculate x2, and okay, it's positive for 6, because before that positive, after that positive, we don't need to calculate. Also, we should calculate endpoints. So we should calculate negative 2 and 8. So let's calculate these 3 points. From assumption of the problem, we know that f of 2 is 1, so we need to calculate only negative 2 and 8. So for negative 2, we know f of 2 minus f of negative 2 is integral of 0 to negative 2 to 2 f prime of x dx. Okay. F of 2 is 1. We want to calculate f of negative 2. If we want to calculate from negative 2 to 2, we should calculate this area up to this part. Okay. So this part that is on top of x-axis is 2 times 1 over 2. 2 times 1 over 2, and but next one you should consider negative because it is below x-axis. So height is 2, base is 1, 2, 3. So it will be 2 times 3 over 2. You can cancel this. It will be 1 minus 3, which is negative 2. And if we want to calculate f of negative 2, f of negative 2, if you take it to right side, is 1. You take negative 2 to left side, plus 2, 3. So if I draw a table, let's consider x, f of x, negative 2, 2, 8. For negative 2, it is 3. For 2, it is 1. Now let's calculate 8. For calculating 8, I say that f of 8 minus f of 2 equal to 2 to 8, f prime of x dx. We know f of 2 is 1 from assumption of the problem. From f of 2 to 8, we should calculate this area, and the red area. Red area is this part plus this part. So area of blue part is 1, 2, 1 to 2 times 2 over 2 plus area of red part. You can say, okay, let's calculate this rectangle minus this semicircle. Okay, the rectangle is what? 2 times 1, 2, 3, 4. It will be 2 times 4 minus area of this rectangle minus this semicircle. Semicircle is what? Pi times 2 squared r squared over 2 because it's a semicircle. And if you simplify this, it will be 2, 2. It will be 2 plus 2 times 4, 8. Minus, we can cancel this, 2 pi. So it will be 10 minus 2 pi. Now, f of 8 minus 1 is that. So if you add 1, it will be 11 minus 2 pi. So f of 8 is 11 minus 2 pi. Now we want to find absolute minimum. Obviously, 1 is the answer. Because 11 minus 2 pi is around 3.14. And is around 6 point something. If you subtract, it will be greater than 4. Okay, so the answer here is f of 2 equal to 1. Okay, so we work on this problem. If you want to improve your problem solving, as I said before, you can use my previous videos in AMC BMO. And if you want to work on a specific part, as I said before, feel free to send message to my WhatsApp number in the description comments. Problem number 5, the functions f and g are twice differentiable. The table shown gives values of the functions and their first derivatives at selected values of x. Part A, let h be the function defined by h of x equal to f of g of x. Find h prime of 7. Show the work that leads to your answer. Okay, now we use chain rule. We know that h prime of x equal to f prime g of x times g prime of x. So h prime of 7, the problem wants that. If you replace x with 7, it will be f prime of g of 7 times g prime of 7. G here, g of 7 is 0, so it will be f prime of 0 times g prime of 7 is 8 times 8. F prime of 0 is 3 over 2, so it will be 3 over 2 times 8. We can cancel 2, it will be 3 times 4, 12. Part B says, let k be a differential function such that k prime of x equal to f of x squared times g of x is a graph of k concave up or concave down at the point where x equal to 4. Give a reason for your answer. Okay, for this part, we should calculate k double prime of x at x equal to 4. We know k prime of x equal to that, f of x squared times g of x. We use product rule and find k double prime squared equal to 2, f of x times f prime of x times g of x plus f of x squared times g prime of x. Now we can conclude k double prime of 4 equal to 2f of 4, f prime of 4, g of 4 plus f of 4 squared g prime of 4. And then we can say 2 f of 4 is what? F of 4 is 4 over 2, 4. F prime of 4 is 3. G of 4 is negative 3. Plus f of 4 squared is 4 squared times g prime of 4 is 2. And then if we calculate this part, 3 times 3, 9. 9 times 4, 36. 36 times 2, 72. We have negative 72. Plus 2 times 16 plus 32. So it will be negative 40. So because it is less than 0, we can say k concave down at x equal to 4. Part C, let m be the function defined by m of x equal to 5x cubed plus integral from 0 to x f prime t dt. Find m of 2, show the work that leads to your answer. Okay, so if we replace x with 2, m of 2 equal to 5 times 2 cubed plus 0 to 2 f prime of x, or let's say f prime of t dt. 5 times 2 cubed is 8, 5 times 8, 40, plus 0 to 2 f prime of t dt. It will be f of 2 minus f of 0. F of 2 and f of 0. If we use our table, f of 2 is 7, f of 0 is 10. So 7 minus 10. 40 plus 7 minus 10. 7 minus 10, negative 3. 40 minus 3 will be 37. Okay, so the answer for part C is 37. Part D, last part, it says it's a function m defined in part C, increasing, decreasing, or neither at x equal to 2. So we should calculate m prime of x at x equal to 2. Okay, let's calculate m prime of x, or dm dx, equal to 5x cubed will be 15x squared plus d dx, 0 to x, f prime of t dt, and it will be 15x squared plus f prime of x. It is what is m prime of x. Now x at x equal to 2, so m prime of 2 equal to 15 times 2 squared plus f prime of 2. 2 squared is 4, 4 times 15, 60, plus f prime of 2. F prime of 2 is what? Is negative 8. So plus negative 8. So 60 minus 8 is 52. Now because 52 is positive, so we can say m is increasing at x equal to 2. Okay, so we've solved this problem completely. As I said before, if you want to improve your problem solving in any part of mathematics, feel free to send message to my WhatsApp number in the description and comments. Also, you can use my previous videos, last AMC, last AME, last PMO. You can use all those things to improve your problem solving. Problem number 6. Consider the curve given by the equation 6xy equal to 2 plus y cubed. Show that dy dx equal to 2y over y squared minus 2x. Okay, when we have something like this, we know 6xy equal to 2 plus y cubed. We take derivative with respect to x from both sides. 6xy equal to d dx. 2 plus y cubed. Left side is what is, we can say 6 by product rule. 6y plus 6xy prime equal to 3y squared by chain rule y prime. Now we can say 6y equal to, we take this to right side, 3y squared y prime minus 6xy prime. And if we factor from y prime, it will be 3y squared minus 6x. Now we divide both sides by this, so y prime, and switch left hand side and right hand side. Y prime equal to 6y over 3y squared minus 6x, and here if we divide both numerator and denominator by 3, it will be 2y y squared minus 2x, and it is y prime. Y prime is what? Dy dx, so dy dx equal to 2y over y squared minus 2x. So we've solved part A. Part B. Find the coordinates of a point on the curve at which the line tangent to the curve is horizontal, or explain why no such point exists. Okay, if the line tangent to the curve is horizontal, means dy dx should be 0. So when dy dx is 0, you know dy dx is 2y over y squared minus 2x. So we conclude numerator is 0, 2y is 0, so y equal to 0. Now if we check, let's call this one star. If we replace in a star, it will be 6x times 0 equal to 2 plus 0 cubed. So right side is 0, is 2, left side is 0. So we've concluded 0 is equal to 2. So it's not possible. So we conclude what? No such point exists. Let's solve part C. Part C. Find the coordinates of a point on the curve at which the line tangent to the curve is vertical, or explain why no such point exists. For this part, we know that dy dx, that is 2y over y squared minus 2x. So because it is vertical, denominator should be 0. So y squared minus 2x should be 0. So y squared equal to 2x. And from star, main equation of the problem, we know that 6xy equal to 2 plus y cubed. 6xy equal to 2 plus y cubed. Okay. Now let's consider, we want to find x and y. Because here y squared is 2xy, we can conclude that if we multiply both sides by x squared, here we have y cubed. So let's multiply both sides by y, it will be y cubed equal to 2xy. Then we can say, so 6xy is 3y cubed equal to 2 plus y cubed. We can subtract y cubed from both sides, 2y cubed equal to 2. So if we divide by 2, y cubed equal to 1, so y equal to 1. And if we replace y equal to 1, 1 equal to 2x, so x equal to 1 over 2. So for this point, we found that the line tangent is vertical for this point. So we can say the coordinate is 1 over 2 and 1. Part D. A particle is moving along the curve at this instant when the particle is at the point 1 over 2 and negative 2. Its horizontal position is increasing at a rate of t dx dt equal to 2/3 unit per second. What is the value of dy dt? The rate of change of the particle's vertical position at that instance. Okay, for this part, we should calculate dy dt. And because we have, we can say it is equal to dy dx times dx dt. dy dx, we have the formula from assumption of the problem, and from part A, 2y over y squared minus 2x times dx dt, the problem says is equal to 2/3. Now it says at which point? At the point 1 over 2 and negative 2, so y is negative 2. So 2 times negative 2 over negative 2 squared minus 2 times x means minus 2 times 1 over 2 times 2/3 equal to 2 times negative 2 is negative 4. Negative 2 squared is 4 minus 1 times 2/3. It will be negative 4 over 3 times 2/3. And it will be negative 8 over 9, it says what's the value? The rate of change of particle vertical position at that instant. So we can say negative 8 over 9 units per second. Okay, so we found this part. Okay, so if you, as I said in previous problems, if you want to improve your problem solving, you can use my previous videos, and you can feel free to send message to my WhatsApp number in the description comments. If you want to work on specific parts, it is not important on what part, how hard it is. We can work on that and learn how to approach different